So next question on cam and follower is having flat face follower with radial position. So first we'll draw a base circle having radius RC. After then vertical line passing through center points and the flat face follower. Now we'll divide this base circle in different angles like phi A, delta 1, phi D and delta 2, and we'll divide this angle of ascent in 8 equal parts from 0 to 8. After then we'll draw lines start from center points passing through each points, and we'll mark the displacement points on each line. And next we'll draw face of the follower on each points, and the final cam profile will be tangent to all face. So this is the cam profile. Like this we will complete this numerical. So the numerical is a flat face follower is operated by a uniformly rotating cam. The follower races through a distance of 25 mm. So h is equal to 25 mm and phi A is 120 degree and delta 1 30 degree. And phi D is given as 120 degree and delta 2 is 90 degree. And follower rise with cycloidal motion, and the follower return with uniform acceleration and deceleration. And the least radius of the cam is given as 25 mm, which rotates at 300 rpm. So we can say speed of the cam is given as n is equal to 300 rpm. So the final we have to draw a cam profile and determine the values of maximum velocity and acceleration during rising. So we can say omega is 2 pi n by 60, so simply 31.4 radian per second. Now we'll draw follower displacement diagram. So first we will make a box, rectangle box, and in this horizontally we'll take phi A, and in vertical side we will take a displacement h. We'll go for actual dimension of displacement, that is 25 mm, but at horizontal side we have phi A, that is angle of ascent, so that is 120 degrees. So we'll take a suitable scale and we'll divide this phi A in 8 equal parts. After then we will draw a diagonal and we'll draw a circle having radius h by 2 pi. In this we'll draw parallel lines of the diagonal like this from 2, 1, 3, 1 points, 0, 8, 4, 1 points, 5, 7, 1 point, 6, 1 point. So total 5 lines we will draw parallel to the diagonal. And now we will mark from 0, 0 dash, 1, 1 dash, 2, 2, 2 dash, 3, 3, 3 dash, 4 dash, 5 dash, 6 dash, 8, 7 dash and 8 dash. Like this we will complete this follower displacement diagram when the follower rise with cycloidal motion, and in this is the final displacement curve for cycloidal motion. Next is 30 degree 12. So we'll make a rectangle box and we'll draw what horizontal line. Next we'll make uniform acceleration and deceleration. So in this we will make this vertical rectangle box, and in this we will divide this phi D in 6 equal parts, and also the center line we will divide in 6 equal parts. Now we'll draw a diagonal like this, and we'll draw lines like this. Now we'll mark the points 6 6 dash, 5 5 dash, 4 4 dash, 3 3 dash, 2 2 dash, 1 1 dash, 0 0 dash. And this is final displacement curve when the motion is uniform acceleration and deceleration, and this is the second dwell, that is angle 90 degree. So that is displacement diagram. And now we will draw cam profile. We'll draw a base circle and we'll divide this base circle in different angles phi A, delta 1, phi D and delta 2 like this. Now we'll divide this phi A in 8 equal parts, and also in phi D we will divide this in 6 equal parts. After then, as the position is radial, so we'll draw lines start from the center points passing through the points like this. Same for phi D also. Next we'll mark the displacements on each line from 0 dash to 8 dash and from 6 dash to 0 dash like this, and we'll draw face of the follower normal to each line like this for phi A and phi D. And the final cam profile will be tangent to each face. We can say this is the final cam profile. Now this is the final cam profile, and we have to find out the maximum velocity and acceleration during ascent. So we have a motion is cycloidal motion, so maximum velocity is 750 mm per second, and maximum acceleration is this 35 310 mm per second.